Hello everyone, welcome to Math Side Trips, a channel for math teachers, students, coaches, trainers, and enthusiasts. Thank you for sparing time and effort to visit this channel. Many of the topics that have been discussed and will be discussed in this channel are those that are not usually taken up in mainstream classroom instruction. We hope that you will find in this channel something new, interesting, or useful. In this video, the discussion will focus on the three-point form equation of a parabola, this time when the parabola has horizontal axis. So this is our channel name, Mathematical Side Trips. So this is a follow-up discussion on the previous topic, the three-point form equation of a parabola whose axis is vertical. By the way, I am Napoleon A. Gaking Jr., a math teacher. Okay, this has already been mentioned in the preceding video, but I would like to mention this case or cases again. There are 4 cases as a reminder of what we have discussed in the preceding video. So in the preceding video, recall that given 3 non-collinear points, p sub 1, p sub 2, and p sub 3 in the plane, there are 4 possible cases to consider. A, if exactly 2 of these points lie on a line parallel to the x-axis, then the axis of the parabola is parallel to the y-axis. B, if exactly 2 of these points lie on a line parallel to the y-axis, then the axis of the parabola is parallel to the x-axis. Letter C, if no 2 of these points lie on a line parallel to either axis, then there are 2 parabolas containing these points. One has vertical axis and the other has horizontal axis. Case letter D, if these points form a right triangle whose sides are parallel to the x and y axis, then the axis of the parabola is neither horizontal nor vertical, and discussion of this case will not be done here. Case A and the first half of case C have been taken up in the preceding video. So now we'll consider case B and the second half of case C. So we have this theorem. Suppose p sub 1, p sub 2, p sub 3 are 3 points lying on a parabola whose axis is horizontal. Then its equation is given by this equation. So take note that the roles of the x's and the y's are simply interchanged. And so this is still called the three-point form equation of a parabola whose axis is horizontal. So note that except for the reversal of the roles of the x's and the y's, the form is essentially the same. The proof is analogous to that of the one in the preceding video and will be omitted here. Let us consider instead some examples. Okay, example number 1. Find an equation of the parabola containing the points p sub 1, p sub 2, and p sub 3 using the three-point form equation. Okay, so the coordinates of p sub 1 is 5, 8. P sub 2 has 1, 1, and P sub 3 has 5, negative 1. Solution. Notice that P sub 1 and P sub 3 lie on the same vertical line because their abscissas are the same, 5. So the axis of the parabola is horizontal. Plugging these coordinates into the formula, we obtain, okay, that equation which simplifies to this expression and to this expression, to this expression, and finally to the expression 1 over 7 times the quantity 2y squared minus 14y plus 19. So that is the equation of the parabola. Solution number 2, for computational convenience, interchange the coordinates of P sub 2 and P sub 3. So now we have instead P sub 1 has coordinates 5, 8, P sub 2 has coordinates 5, negative 1, and P sub 3 has coordinates 1, 1. And using the same formula, plugging in the given values, we have this expression which simplifies to this expression, and finally we have 2y squared minus 14y plus 19 over 7, which agrees with the first result. Example number 2, the parabola y equals negative 3 halves x squared plus 6x minus 2 contains the points P sub 1 with coordinates 0, negative 2, P sub 2 with coordinates 2, 4, and P sub 3 with coordinates 6, negative 20. Use the 3-point form to find the other parabola containing these points. Okay, solution. As noted in the preceding video, there are 2 parabolas containing these points. The other parabola has horizontal axis and has equation. Okay, so when we plug in the values, given values in the 3-point form for a parabola of this type, then we have this expression or equation which simplifies to this equation, and then we have another reduction of the preceding expression on the right hand side, and finally we have y squared plus 10y plus 16 over 36. So that is the equation of the parabola. X equals y squared plus 10y plus 16 over 36. Example number 3, find the 2 parabolas containing the points A, B, and C. A has coordinates 3, 6, B has coordinates 5, 0, and C has coordinates negative 1, 2. Now, the parabola with vertical axis has equation, okay, using the first form, we have this, which simplifies to negative 2x squared plus 7x plus 15 over 3. So the parabola whose axis is vertical has equation y equals negative 2x squared plus 7x plus 15 over 3. On the other hand, the parabola containing these points with horizontal axis has equation, okay, this one, plugging in the values, we have this expression which simplifies to this expression. And finally, we have 2y squared minus 13y plus 15 over 3. So the equation of the parabola whose axis is horizontal is x equals 2y squared minus 13y plus 15 over 3. A rough sketch of the two parabolas follows. This one here, drawn on a graphing paper. So that is all for now. We hope that you have learned something new, interesting, or useful. The next videos are about construction of equations in some variable by starting with the solution of the equation or the root of the expression. Or number 2, embedding the solution somewhere as the construction progresses. God bless.